Have you ever wondered why the Philippines floods so often? You know, it's a country of more than 7,000 islands, and it sits right in the path of many powerful storms called typhoons. Every year, these storms bring heavy rain, and this rain fills up rivers and streets very quickly. This creates a huge challenge for the people who live there, and honestly, it also creates a big job for a special group of people. These are the Filipino engineers. They're the problem solvers who work hard to keep communities safe and dry. Their work is incredibly important for the nation's survival and progress. These engineers are on the front lines of a constant battle. They're fighting against nature itself. Their main goal is to manage the water, and this is called flood control. It means building things that can hold, block, or redirect the floodwaters. Let's look at how other countries handle floods. In the Netherlands, engineers have built something incredible. It is called the Delta Works. This is a massive system of dams, barriers, and dikes. It is so advanced it is considered one of the modern wonders of the world. These structures can close off entire sections of the sea to protect the land behind them. Now let's travel to Japan. This country also faces intense rain and typhoons. In Tokyo, they built a huge underground system. It is called the Metropolitan Area Outer Underground Discharge Channel. Think of it as a giant, secret underground river. When smaller rivers start to overflow, the water is diverted into giant tunnels. These tunnels are big enough to park a space shuttle inside. In the Philippines, the approach is often different. Engineers must work with much smaller budgets, so they focus on more direct and localized solutions. You will see a lot of concrete river walls, also known as revetments. They also build dikes, which are long mounds of earth to hold back water. Another common project is dredging. This means scooping out mud and debris from riverbeds, making the rivers deeper so they can hold more water. The key difference is scale and technology. World-class systems like those in the Netherlands and Japan are integrated. They are huge networks that work together, managed by advanced computer systems. Philippine projects are often more localized. They protect a specific town or a single riverbank, and they rely more on traditional construction methods rather than cutting-edge robotics or predictive AI. Filipino engineers have a special kind of superpower. It is called ingenuity. This means they are incredibly resourceful. When you do not have a big budget or the latest technology, you have to be clever. You have to find smart ways to solve problems with the tools you have. This is where Filipino engineers shine. They are masters of adaptation. One of the biggest challenges they face is the country's geography. The Philippines is an archipelago. This means it is made up of thousands of islands. Building one giant connected flood control system like in the Netherlands is simply impossible. Each island has its own unique landscape, its own rivers, and its own flood problems. So engineers must create customized solutions for each location. Climate is another huge factor. The Philippines is in the tropics. This means it gets a lot of rain, especially during typhoon season. The storms are becoming stronger and more unpredictable due to climate change. Engineers have to design structures that can handle these extreme weather events. They are constantly trying to stay one step ahead of Mother Nature. This combination of limited funds, complex geography, and severe weather creates a unique engineering culture. Filipino engineers are experts at what is called appropriate technology. This means using technology that fits the local context. Instead of a complex computer-operated dam, they might design a simple but effective earth dike that can be built and maintained by the local community. This focus on realistic, achievable solutions is the hallmark of Filipino engineering. Let's look at a real-world example of a major project. The Pasig-Marikina River Channel Improvement Project is a big one. This project aims to protect Metro Manila from the overflowing of two major rivers. For years, these rivers would swell during typhoons and cause massive flooding in the city. The project involved several key activities. Engineers widened the river channels. They dredged tons of silt and garbage to make the rivers deeper. This project has had some success in reducing major flooding in many areas it was designed to protect. However, many projects also face struggles. One of the biggest issues is what happens after a project is built. A new drainage canal is great, but if it gets filled with trash, it will not work. A pumping station is a fantastic tool, but if it is not maintained, its parts will break down. But there are clear successes we can celebrate. The flood control project in the Camanava area is one. This area, composed of the cities of Caloocan, Malabon, Navotas, and Valenzuela, is naturally low-lying and prone to constant flooding. Engineers built a system of dikes, floodgates, and powerful pumping stations. When the water level gets high, the gates close, and the giant pumps push the water out into Manila Bay. While not perfect, this system has significantly improved the lives of residents. It shows that when investment and focused engineering come together, real progress can be made in the Philippines. So, what makes a project work? The successful ones often have strong government support and funding. They also involve the local community from the beginning. When people understand how a project works and why it is important, they are more likely to help take care of it. So how can Philippine engineering become more world-class in the global sense? It starts with a bigger vision. Instead of just fixing one riverbank at a time, we need more master plans. These are comprehensive plans that look at an entire river basin or a whole region. This means studying how all the rivers, mountains, and cities in an area work together. This approach, called integrated water resource management, is what countries like Japan and the Netherlands use. Next, we need to embrace new technologies. Drones can be used to quickly map out flood-prone areas. Advanced computer models can simulate typhoons and predict which areas will flood the most. Sensors placed in rivers can give real-time data on water levels. These tools can help engineers make smarter, faster decisions. While the Philippines may not be able to build a giant underground tunnel like Tokyo's, it can adopt these more affordable technologies. This will help bridge the gap and make local flood control more proactive and data-driven rather than just reactive. Investing in our engineers is also crucial. This means more funding for research and development. It means sending engineers abroad to train and learn about the latest global techniques. It also means creating better opportunities for them at home, so our best and brightest minds stay in the Philippines to solve our own problems. A world-class country needs world-class experts. Ultimately, the journey to becoming world-class is a marathon, not a sprint. The Philippines has the talent. It has the ingenuity. What it needs is the system to support that talent. This means consistent government funding, long-term master planning, adopting smart technologies, and empowering communities to be part of the solution. Filipino engineers are already performing incredible feats with what they have. Imagine what they could do if they were given the tools and support to match their immense potential. They are ready to build a safer, more resilient Philippines, ready for any storm that comes their way.